The overall conviction among most specialists is that the hypothesis of how things came to be stays the major explanation for the early seasons of the universe. This speculation joins the advancement of stars, planets, and in this way forward, life on those planets, counting ourselves. Despite its odd name, the enormous detonation, it offers an enlightening evaluation concerning what might have happened at first. The universe was thick in a short space, more thick than a pinhead, with particles thickly pressed. From this second, a beast impact of issue and energy happened, known as the enormous detonation. This occasion, happening billions of years prior, set up the spreading out of huge history. In any case, in sensible data, it has set off making peculiarities with the suppositions of this speculation. Right when NASA sent off the James Webb Space Telescope, the biggest and most developed space science observatory ever, specialists evaluated that its understanding would affirm the speculation of the universe's beginning stage. Unfortunately, after just a single year in space, the telescope paralyzed specialists with its capacity to peer so profoundly into the universe's past. The James Webb Telescope's stunning capacities have uncovered incalculable universes, going as far back to a period so old that it challenges how we could decipher the universe's starting points. This revelation has begun an extreme assessment concerning what existed before the enormous bang. One urgent moment in this mission happened when cosmologist Rohan Naidu, working with information from the telescope, suddenly tracked down a framework from just a short time frame after the enormous bang, making it the most far-off universe at any point seen. Naidu's revelation sent shockwaves through laid-out specialists, highlighting the astounding skills of the James Webb Telescope. Its colossal potential to have a significant impact on our viewpoint on the universe has scarcely begun, promising to uncover astonishing bits of knowledge into the earliest times of the universe's presence. This period, barely engaged on ahead of time, holds the key to getting a handle on the improvement of the first stars and universes. The telescope's disclosures have conflicted with head speculations, uncovering frameworks with credits outmaneuvering past presumptions. This extraordinary surge of early universes has started a tempest of logical request, testing specialists to adjust these disclosures to existing speculations. As investigators uncover these openings, they face key inquiries regarding the actual nature of the universe and the powers that molded its turn of events. Beyond the James Webb Telescope's benefits, which are clear, it is seen as 1.5 million kilometers away from Earth, protected from endless obstruction, and cooled to move toward absolute zero by its tennis court-sized sun safeguard. The telescope consolidates an enormous piece reflect and incredibly delicate instruments, designed to uncover subtleties of the early universe that were previously confidential. This period, known as the infinite daybreak, happened around 200 to 300 million years after the enormous detonation, marking the occasion at the point when the first stars and cosmic systems began to form. The interaction by which this unfurled remains a subject of perfect order, with speculations ranging from the impacts of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's perspective on systems from the enormous first light presents a clever chance for cosmologists to test how they may decipher these intricate parts. By concentrating on these antiquated frameworks, experts can either affirm the legitimacy of their ongoing models or reveal holes in understanding that could lead to major new disclosures. The telescope was supposed to take note of a couple of frail and little universes in its pilot studies. However, the truth has far surpassed these assumptions. The telescope's early pictures of the far-off universe uncovered an overflow of universes with ages, sizes, and splendor levels that resisted all forecasts. This stunning flood of early systems has started a race among space specialists to lay out new standard records for the earliest known monstrous frameworks, with new relations arising continually, leaving customary experts in wonder. Following the James Webb Telescope's openings, informed authorities and spectators have hustled to concentrate on the presence of these incredibly advanced early universes. Some estimated that mistakes in the telescope's interpretation of huge perceptions could be liable for these disturbing disclosures. That said, the agreement states that these disclosures represent a change in perspective by the way we could decipher the early universe and offer invigorating looks into the potential for colossal headway. The new disclosures from the James Webb Space Telescope about systems have raised critical questions in regards to the nature of the universe and tested the presumptions of standard cosmological models. While some experts are examining whether these experiences can be obliged with existing hypotheses, others propose that they might be the primary signs that the universe is undeniably more confounded and confounding than previously envisioned. The vital inquiry in play is our essential comprehension of how the universe we know arose out of early-stage disorder. The early discoveries of the JWST could reshape our core thoughts of vast history, uncovering bits of insight not just on far-off worlds and old designs, but also on the actual nature of our own Milky Way. As Mark McFan, senior researcher for science and investigation at the European Space Organization, puts it, "You build these machines not to confirm speculations, but to break them. You just have no clue how it will break." The beginnings of the JWST can be traced back to the Space Telescope Science Foundation, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with envisioning what could come after Hubble. Despite initial doubts, Weir and a small group began laying the foundation for what would ultimately become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared range, allowing it to peer much deeper into the universe. This capability is critical for studying distant galaxies, whose light has been stretched into the infrared due to the expansion of the universe, making them undetectable to telescopes like Hubble. With its huge, cold, star-like mirror, the JWST became the head instrument for uncovering the secrets of the vast unknown. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation revealed countless galaxies in what was once thought to be an empty patch of sky. This discovery illustrated the wealth of the early universe and highlighted the need for a telescope capable of probing even deeper into cosmic history. Following years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Early initiatives like the Early Release Science Program and the General Observing Program were specifically designed to search for early galaxies. While initial assumptions were modest, the results far exceeded expectations. JWST observations have challenged existing models of the early universe, uncovering galaxies that defy traditional cosmological assumptions. These stunning discoveries emphasize the importance of pushing the boundaries of scientific inquiry and showcase the remarkable capabilities of cutting-edge technologies like the James Webb Space Telescope. As researchers continue to explore JWST data, they may uncover further insights that test and expand our understanding of the universe. When the first data began coming in from the JWST, cosmologists eagerly anticipated the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which typically takes months, scientists chose to share their discoveries on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new kind of peer review to take place through online platforms like Twitter, where established experts could immediately discuss findings. Rohan Nada described this process as science by press release, and the ensuing storm of conversation was both intense and surprising. However, there were concerns about the potential downsides of this rapid dissemination of results. Klaus Pontypool, a JWST project researcher at STSCI, warned that while the quick sharing of results facilitated rapid distribution and discussion, it also carried the risk of overwhelming the process. The general understanding among most scientists is that the speculation of how things came to be remains the primary explanation for the early times of the universe. This theory ties together the development of stars, planets, and life on those planets, including ourselves. Despite its odd name, the Big Bang Theory offers a convincing explanation for what could have happened at the universe's origins. The universe was densely packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the unfolding of cosmic history in motion. However, changes in scientific data have led to anomalies with the assumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, researchers estimated that its observations would support the theory of the universe's beginning. Unfortunately, after just 1 year in space, the telescope confounded scientists with its ability to peer deeply into the universe's past. The James Webb Space Telescope's capabilities have revealed galaxies dating back to such ancient times that they challenge how we could interpret the universe's origins. This discovery has sparked a serious reassessment of what might have existed before the Big Bang.